Alright, this is 5.2. We're going to solve systems of linear equations using substitution, a different method to solving systems of linear equations. Alright, so when we solve the system of linear equations using substitution, we're trying to find the values of x and y that fit both equations in the system. So just to keep everything straight, I'm going to label my equations 1 and 2, and I'm going to use the colors to color code which equation I'm going to be manipulating or working with when you watch this video. When you're using substitution and you have two equations in your system, the idea is that you want one of your equations to be already set equal to a variable. So in either the first equation or the second equation, I noticed that my first equation, y equals 3x plus 8, well, the y variable is already set equal to something. That expression is 3x plus 8. So for some reason, our y is equal to 3x plus 8. Okay, you got to get into your brains that it's okay to have an expression set equal to a variable. It doesn't have to equal an actual number, but that 3x plus 8 will represent the answer to the value of y. So since y is already equal to 3x plus 8 in the first equation, well, I'm going to take my second equation, x plus 2y equals 5, and I'm going to substitute in the 3x plus 8 into the y of the second equation. Because my y is equal to 3x plus 8, so then I have x plus 2 times the quantity, 3x plus 8, and equal to 5. So then I'm going to simplify my equation. I'm going to distribute my 2 to my 3x and 2 to my 8 using multiplication. So I get x plus 6x plus 16 equals 5. I'm going to simplify further. And then subtract 16 from both sides. And finally divide both sides by 7. So then my final answer for x is equal to negative 11 over 7. So some of you might be thinking, did I do something wrong? It's a fraction, I don't know what I'm doing, yada yada yada. Alright, so there's a method to double check to see if you are doing this correctly. Well, let's first solve for our y variable. So before solving for your y variable, just make sure that you, again, if you're just second guessing your answer, just go back through your steps and see if you made a small mental or mathematical error. But if you are good to go, just let's solve for the second variable y. So I'm going to write down the first equation in my linear system, and I'm going to substitute my value of x into my x variable in the first equation of my linear system. So when I simplify further, y equals negative 33 over 7 plus 8, and I use my calculator to get y equals 23 over 7. So I have both fractions in my system, so x equals negative 11 over 7 and y equals 23 over 7. So that looks like it's a completely different answer and it's wrong because you have fractions, yada yada yada, but if you have your x and your y, you can check to see if it satisfies the equations. So since I've used both equations in my system to figure out the values of x and y, I'm going to substitute these values into one of the equations to see if it checks out. So just to separate some space, I'm going to take my second equation in my system, it's marked in red, and I'm going to substitute my value of x in and my value of y in for my in for my y in the second equation. So then I'm going to simplify. I have negative 11 over 7 plus the 2 times 23 over 7. And we have to check to see if that equals to 5. Normally, if you get an integer value for your x and y's, a lot of us don't complete our checking system, but we have to double check to see if this left side of my equation will equal that 5. So if I have negative 11 over 7 plus 2 times 23 over 7, that actually ends up being 46 over 7. And when I add these two fractions together, I get a 35 over 7 equals 5. And that actually checks out. We have a 35 divided by 7 equals 5. we have 100% success, and we know that our final answer is negative 11 over 7 as x, and y equals 23 over 7. So how you'd write that down, I'm going to use a space here. We have, in an ordered pair, negative 11 over 7, comma, 23 over 7. So the second example, solve the linear system using substitution, is a little bit more advanced than the previous example. Now what I suggest that you try doing is try the example on your own, see why it's advanced, and then if you need to, continue the video on after pausing it and seeing what my solution is. If you let the video play, well, here's the hint. I'm going to label my equations 1 and 2, use the colors just to color code what equations I'm working with, and I need to set one of my equations equal to one of the variables. So I'm going to take my first equation because I see that, I don't know, I just picked that one out just because I wanted to. X minus 3y equals 2, and I need that equation set equal to a variable. Because my x has a coefficient of positive 1, I'm just going to add the 3y to both sides so that I have x equals to 2 plus 3y. Now that I have my x equal to a variable, my x equal to an expression, x is all by itself, x is equal to 2 plus 3y, I'm going to use my second equation to substitute in my x to figure out the y value. So go from there and see if you can do this on your own. Pause the video, and then if you want to continue it on or just continue listening, feel free to do so. But I suggest that you try to do this on your own. So there you go. So in an ordered pair, x equals 5 and y equals 1, I'm going to use this space on the left. So it would be 5, comma 1 as our answer. Thanks again for watching, guys, and hopefully you guys wrote down any questions that you may have had while watching the video, and I'll see you guys in class.